It's a great pleasure to be with you here today, and I also want to extend my thanks to the professor and the good doctor, and in particular to all of you. Can you hear me okay? In particular, all of you students. Hopefully you understand that we're here recruiting, so we're looking for the top IT performers here. We're in a global business. It's doing quite well, and there's always room for more munitions in IBM. I think it's appropriate that I be talking to you about IBM's 100th birthday today, because I've been with the company all 100 years, as you can see. The nice part about going to college is you get a college picture. I do think it's important that we do reflect, when we see the pervasiveness of computing today, we sometimes forget the historical context in how we got here. This is the celebration of IBM's 100th year in computing, which honestly is pretty amazing. When you think about any company today to have been around 100 years, it really is quite an achievement. And I think there's a lot that we can learn from that. In fact, in 1962, in 1962, Thomas Watson Jr., the son of the founder, was giving a speech to leaders in industry and society, people like yourself. And IBM had just celebrated its 50th year in business. At that speech, he noted the following: there were only 2 companies in 1962 that were in the Fortune 500 from 1900. Only 2 remained. And if you think about it, if you looked at today, from 1962, from the time of his speech until today, of the top 25 Fortune 500 companies, only 4 are in the top 25 in 2011. So it really is a remarkable achievement when you step back and think about being able to succeed for so long. I don't want to spend all of our time, nor did we design to spend all of our time, celebrating the past, however. At IBM, we saw this 100th year as a very important opportunity to engage with governmental institutions, educational institutions, and other businesses in looking forward and saying, what are the lessons that we've learned, and what do we take forward as the challenges coming up? And I think there's some very exciting ones. We're going to go through 3 basic questions here, or 3 basic observations over the last 100 years. The first is the nature and implication of information technology itself, the role that it's played in shaping society. The second is, I think we're at an inflection point in this industry. About every 20 or 30 years, we reach a point where the technology allows us to think about solving an entirely different set of transformational problems. And I'll share some of those with you. It's why I think information technology is really prepared for a golden age going forward. And finally, we'll talk about the implications of that change on you, on me, on our societal institutions, on our business leaders. And I really think there's a call to leadership that we can all learn from. Now, I think the biggest lesson of 100 years is that IT matters. IT matters. Perhaps more than any other science or technology over the past century, information technology has shaped the world more powerfully than any other science I can think of. 100 years ago, brought in the mechanical calculation technology, the punch card tabulator. 100 years ago, you know, you were saying just what was going on in 1937 in Indonesia for IBM to be doing business. 100 years ago, the punch card tabulator, mechanical machine, for the first time allowed a transformation in some foundational industries that were growing around the world. It was the first time that you could count the rolling stock of the railroad industry. It was the first time that governments could take censuses to know where their people were, to begin doing planning, civil planning, and for taxation and things, other services that governments provide. It was the first time that you could calculate banking deposits and keep them in a fashion that you knew with certainty had some integrity. So 100 years ago, the mechanical tabulator, the punch card tabulator, had a huge impact on society. About 50 years ago was when we, as a group, invented the electronic data processing industry. And IBM played a huge role in that with a $5 billion bet on the System 360 and the series of mainframes. That allowed us for the first time to do online transaction processing. It fundamentally changed industries again. Think about, for instance, that's what allowed airline reservation systems to exist. It's what allowed complex scheduling in the airlines industry to exist. It allowed online transaction banking for the first time. It fundamentally changed the retail industry by connecting inventories with front office sales. So just 50 years ago, we had this, again, this transformational impact from electronic data processing. Believe it or not, it was 30 years ago that we introduced the personal computer, a hugely empowering technology that allowed for the first time you as a personal productivity tool, but also you to speak with other members of society and form groups, and allowed us to begin to transform the individual experience around computing. And then 15 years ago, brought on the dawn of the internet, which has been the most transformational change in this industry in those 100 years. Now we have billions of people that can interact, and we are able, from a business standpoint, to take on the challenge of, it has broken down the challenge of time and space, allowing us to move different parts of the business all over the world, and in large part, I think, is a key to why this area of the world is growing so quickly and becoming part of a globally integrated world. There were six major technologies that occurred during this period. Sensing technology. The first computers sensed through the punch card. So it was touch. That was nearly 60 years ago. 60 years ago, computers began to decipher speech. It's the longest running research and development program inside of IBM. Our first research project there was called Shoebox in 1960. It could decipher 18 words. 18 words. Think about today. Anybody own an iPhone 4S? Yeah. Think about the capability in there. By the way, an average car that's produced today has a vocabulary of over 10,000 words. Over 10,000 words. So now we begin to see the impact of speech. IBM introduced the barcode and transformed fundamentally the entire retail industry. That was the first time that computers had visual insight. And today, we know that that sensing technology has gotten to the point where if you look at the high-speed rail of Taiwan today, we monitor over 320,000 sensors at any given point in time and are able to predict what's happening throughout the entire line. So sensing technologies changed dramatically over the years. The second one is memory, the fundamental building block of the computing industry. From 1950 to 2010, the amount of information stored on a disk increased by a factor of 17 million. The speed at which it could be accessed increased by 8,000 times, and the cost dropped 1 million-fold. Now imagine if that would have happened in the auto industry. You could drive at 500 miles per hour and buy a car for $1. Think about that. What other industry has transformed with that kind of, with those kinds of numbers? A gigabyte of storage today, which is about an hour of video, in 1980, it took a 500-pound machine the size of a refrigerator to store a gigabyte of data. Today you can do that on a coin. On a coin. In fact, in 2015, it's projected that we will produce 28 zettabytes of data around the world. A zettabyte is 10 to the 21st. One with 21 zeros after it. It's a lot of zeros. You know what I mean? Processing power. The processing power that we have in an average automobile today is 100 times greater than what we had on board to send man to the moon. Think about just that short period of time. Finally, logic. Logic is another key. You know, we speak to computers. They only have two states, on or off. We speak to them in programming languages. We were joking about Java. Very appropriate. We have gotten to maybe the most, which I'll talk about in a few minutes, one of the most sentinel discoveries that we've had in the computer industry just came out of IBM's research labs with this product we called Watson. This is natural language understanding of the computer. A computer that understands natural language and learns as it goes along. We'll talk about the implications of that in just a minute. Obviously, all of you here understand from the connection standpoint, there's ubiquitous bandwidth almost anywhere you go in the world. And finally, architecturally, we're seeing different workloads and different computer designs optimized, and I'll talk about a couple of those. So those are the basic building blocks, and you can see that throughout the history of computing, those things have been emerging and multiplying at just fantastic rates of discovery. So I would argue that we've gone from the tabulating era to the computing era, and now on to the smart systems era. Systems that learn from what they do, that recognize patterns without programming, that make possible a higher order of problem solving, and we can begin to think of completely new transformational opportunities throughout industry. Now, I don't know, how many of you are familiar with the show called Jeopardy? Some? Not many. So this is a question and answer, and it's based on a show in the U.S., was based on nuance of the words. It's quite an advanced TV show, quite seriously done. IBM entered our candidate, named after our founder, Watson. This was not a computer that was attached to the internet. It had its own data storage of 200 million pages of content fed into it by IBM researchers. It was powered by 2,880 processor cores and 15 terabytes of data. The idea was, could this machine outperform the top of the Jeopardy players, the very top level? We took on the two winningest Jeopardy players and beat them soundly. Now, we didn't spend $4 billion to win Jeopardy. We were trying to make the point that we had made some breakthroughs in the natural language and understanding. And the most important thing is if you watch that show, you could watch the computer learn as it went along from the other people's answers. This has huge implications. Imagine natural language applications in healthcare. Imagine a doctor being able to get assistance on complex diagnoses through a capability that exists like this. Or imagine doing stock trading where you don't always have the smartest stock trader, but you could supplement it with this kind of capability. This would have vast informations of deep question and answer type applications. Now, I say we're in a smarter computing era. And I believe that we are at an inflection point in IT, and that the best years of this industry lie ahead of it. And the reason for this, I'd like you to consider a few facts. But I think the most important thing, having driven from the airport last night to the hotel room after 24 hours in an airplane, there are problems that we need to solve transformationally. Like, wouldn't it be nice if we could get from the airport to the hotel in less time than it took us to get from New York to Jakarta? Right? There are big problems around the world. You've probably read we just introduced our 7 billionth person around the world. Food, water are going to become incredibly important things to manage. And we'll talk about some reasons why we ought to consider being part of this change. Now, we live in a world that for the first time has three things in common that I think are going to reshape almost every industry. First, the world is instrumented. We can measure and sense and see the exact condition of everything, both the physical world and the digital world. It's interconnected. People, systems, objects can communicate with essentially every other person, object, or system. And it's intelligent. We can capture enough data about the system to be able to predict outcomes and optimize them for the future. Think of a city. If you think of a city, think of the water system, the traffic system, the public safety system, the electric system. A city is a system of systems. Imagine a city that was instrumented, interconnected, and intelligent, and how it might operate differently from one that isn't. Let me give you some examples of what I think is going on. Today, there are 1 billion transistors for each person on the planet, and they cost 1/10,000,000th of 1 cent. 1 billion, there's more transistors per people than there is rice. 4 billion of us are connected through the world's mobile networks. 4 billion. We have 30 billion radio frequency tags giving us real-time instrumentation of the world's systems, natural and man-made. 2 billion of us are connected on the internet. But more importantly, there are over 1 trillion things connected to the internet. 1 trillion. Appliances, cars, cameras, roadways, pipelines, water systems, trillion interconnected things, all creating data for analysis that can be turned into insight for a better world. Now, I want to just share with you a couple of projects that I think sum up why we're at this inflection point in the industry. The first one is Galway Bay, which is in Ireland. Through a series of smart buoys, these are buoys that are floating out in the bay, we're able to determine the environmental impact of what's going on in Galway Bay. We're able to understand the quality of the ecosystem for the catch, the food, the fish that make up a key part of the economy. We're able to understand major geological trends that have been going on. In a sense, protecting Galway Bay for the future generations of that area of Ireland. All done through a connected system floating out in the bay. And in fact, I was there recently and I watched fishermen coming to market with their catch, also using this information to understand where to fish, how to get that fish to market, get it there at a certain price. There were fishermen coming in on their boats, typing in to the store, coming in on their BlackBerries. I mean, this is quite a sight. These are people that were completely illiterate just a year ago to computer science. In Rotterdam, in the Netherlands, we're working with Rotterdam on what's called a Smart Delta city program. This is real-time capture of information of the oceans, the rivers, the rainfall, the groundwater, and the impact that it has on the city. Why do you care about that? We're sharing that same information with other Delta cities. You know what one of those cities is? One of those Delta cities? Jakarta. Imagine if we took the learnings from 40 of those cities and got smarter about protecting our natural resources going forward. We announced a program with Columbia University, which is having a huge impact through a new technology called streaming, which is taking huge streams of data in parallel to understand the impact of many censored things and having a monumental impact for those who have suffered traumatic brain injury and giving them hope for a better life in the future. In the Rizzoli Orthopedic Institute in Italy, this is 250 researchers serving 150,000 people in this area of Italy. They're doing musculoskeletal research. You can see the results they're having. They expect a 30% reduction in surgery-related hospitalization because of evidence-based medicine. They expect a 60% reduction in imaging requests. And again, imagine the networking effect of taking Rizzoli and combining it with other institutions doing the same kinds of research. Smarter agriculture in Manitoba, Canada. We're able now to measure the entire food supply chain of their cattle, which says that if there is any problem, we know exactly which cow caused the problem and can get it out of the market, which farm, which piece of the supply chain, we know where it was impacted, and can get it out of the market, providing for a much higher quality experience for all Canadians. Microfinance. You know, one of the keys to building the middle class in the emerging markets is being able to quickly and efficiently loan small amounts of money to all the entrepreneurs that exist out there. Microfinancing is a critical piece of that. We're doing work with smarter analytics around who's the best bet in that area. That brings us to a call for leadership. You know, I've spent 35 years in this industry, I firmly believe that the industry has more changes in front of it than it ever has in its history. And I think there are really three calls here that we have to make together. The first is we need to insist on open standards. If you want to make systems of systems work, then we can't have every industry developing to its own set of standards. The water system does need to understand the electrical system, which does need to understand the public safety system, which does need to understand the health system, the educational system, etc. It's that networking effect that will give rise to the biggest insights. The second is we have some policy implications we have to discuss, things like intellectual property. One of the greatest examples I can give you of some really forward thinking in this area is from the Mars Company. They make candy bars. They came to us a couple of years ago and said, you know, they almost lost the cocoa crop worldwide. It's not done in big farms. It's in subtropical areas where there can be all kinds of different diseases. We sequenced the genome for them, the cocoa genome. And they took it, and instead of trying to profit from having the genome, they put that out in the marketplace. Now farmers all over the world have been building on those resistant capabilities of the cocoa genome and have preserved the cocoa crop and made it stronger. We've looked at 90 other crops that we can do this with. That's taking a whole different mindset to intellectual property. We also know that there are security issues that relate in this area. If your system is smart, it can also be hacked. And what are the implications of somebody getting, either a country or a business getting inside of your smarter capabilities? We need to have a social discourse around this if we're going to resolve these issues. And they have to be tabled by the government, by business, and by other interested organizations. Finally, and most importantly, I don't care if you're from IT or not, but if you're going to be a business leader in the future, you need to understand what's going on here in this interconnected, intelligent world. It has vast implications for what you're going to be able to do in your work, in your industry, and it's only if we have people who have taken the time to understand it that we can really take advantage of it. Thank you all for your attention and time. It's been a pleasure to be here with you today. I look forward to continuing the dialogue.